Hi, it's Dr. Weideman. I'm going to show you how to work some problems from Chapter 15 and using the calculators in StatCrunch. So here's a problem here. In a large class of introductory stat students, the professor has each person toss a fair coin numerous times and calculate the proportion of his or her tosses that were heads. One student in the class claims to have tossed her coin 190 times and found only 42% heads. What do you think of this claim? So the first question they ask you is how many standard deviations from is the observed proportion from the expected mean? So if we're tossing a coin, we would expect to get 50% heads. So first thing we need to do is find the standard error for the situation. So the standard deviation of the proportion is square root of 0.5 times 0.5, the mean, the probability of success, probability of failure, divided by the sample size, which was 190, and you've worked that out, you get 0.0363. So now let's just do a z-score for the observed proportion minus what we expected to see divided by the standard deviation. And so this is 2.21 standard deviations below where we expected the mean to be, which would be at 0.5. And then another problem on this one is they ask you this question here: what do you think of this outcome? Is this unusual? So if we remember back to the empirical rule, 95% of the data is within 2 standard deviations. So this would be pretty unusual. So the student's claim could be true because it's unusual, but it still has a reasonable probability of occurring. It's got a pretty small probability. We're in that 2.5% range. The student's claim is probably false because the result is extremely unlikely to occur. And this would be the best answer here. Okay, let's go on to another problem. This has to do with pregnancies. Assume that the duration of human pregnancies can be described by a normal model with a mean of 266 and a standard deviation of 11 days. Answer the following questions. What percentage of pregnancies should last between 260 and 270 days? So here we're just talking about one pregnancy. So we're going to use the mean of 266 and the standard deviation of 11, and we want to know between those two numbers. So let's go to StatCrunch, and we're going to open up just go to the datasets option, and it'll load in just a second. And so we're going to go ahead and go to Stat Calculator Normal. Okay, and remember the mean was 266 days and the standard deviation was 11, and they wanted us to go between 260 and 270 days. So I'll do 260 first. So 2927. So I'm going to calculate to put that down here. So the probability that the pregnancy lasts less than 260 days is 2927. And then go to 270. We're going to change this 260 to 270. And we're going to get a higher likelihood here. So here it's 6419. 6419. And then we want the area in between. If you go back and look at the density tool, we actually want to go between 260 and 270. So remember, we find each area to the left and we subtract. And so when we subtract that, we get about 34.9% of pregnancies are expected to last between 260 and 270 days. At least how many days should the longest 20% of the pregnancies last? So now if we go back to our density tool, now we want to know the longest 20%. So we're going to put in the area of 20% and we're going to put in here a greater than. So the longest 20% of pregnancies last 275 days, or 275.3 if you round off to one decimal place. Now, a certain obstetrician is currently providing prenatal care to 20 pregnant women. So now we're going, the other part was a single pregnancy, now we're going to 20 pregnancies. So what's the mean of this model? The mean's the same. What's going to change is the standard deviation because we have to adjust for the sample size. So we're going to take that 11 and divide by the square root of 20, and that gives us 2.46. And now what's the probability that the mean duration of these patients' pregnancies will be at least 271 days? Now we need to remember in the calculator to change the standard deviation to that new one that we just calculated, 2.46. And we wanted it to be greater than, I think it was greater than 271 days. No, I think it's less than, actually. I think the problem was less than. So it was changed to the duration will be less than 271 days, so about 0.979. Okay, so that's how you work the problems in Chapter 8, I'm sorry, not Chapter 18, this is Chapter 15, using our little density tool. So hopefully this little video will help you get started.